Hello students, I am Nishant Vora. I am from IIT Patna. I have been associated with askIITians since last 2 years. I am here as an in-house expert in mathematics. Okay, so today we will be starting with this topic, permutation and combination. I have divided this topic into few parts so that the learning is efficient. Okay, so let's start with the first topic. Important topics to be covered under this chapter will be fundamental principle of counting. We will see permutations and combination, the basic definition, theorems related to application of PNC, formation of groups, permutation of alike objects, and also we will see permutation of objects taken sum at a time. And then we will cover circular permutations. We will see total number of combinations or selections, problems based on number theory. We will see summation of number by two different ways, distribution of alike objects, and also rearrangement and some important results about points. Fundamental principle of counting. What exactly is fundamental principle of counting? We will use this fundamental principle of counting to count some events without actually counting them. So if I have an event A whose total possible number of outcomes are m, and if I have another event B whose total possible number of outcomes is n, then the number of ways in which both the events can occur together is simply given by m cross n. Okay, m into n. So let's see this through a different example. Suppose let's consider this model. Here T1, T2, T3 are three towns, town 1, town 2 and town 3, and there are three number of routes that are possible from town 1 to town 2, that is R1, R2 and R3, and again there are two routes which are possible from T2 to T3, that are R4 and R5. Now if I want to go from town 1 to town 3, then what are the possible number of ways? Okay, so either I can take R1 between T1 and T2, and I can take R4 between T2 and T3, sorry. Okay, so in similar way there are 6 possible number of ways in which I can go from T1 to T3, and if I use the fundamental principle of counting, then I can directly get what are the number of ways in which I can go from T1 to T2. Either I can take R1 or I can take R2 or I can take R3. So 3 possible number of ways, and for going between T2 for going from T2 to T3 there are 2 possible ways, that is R4 and R5. So directly I can say if I want to go from T1 to T3 there can be 3 into 2, that is 6 number of ways. Okay, let's see this through a different and a simpler example. So if a student is to roll a die and flip a coin, so if I am rolling a die, what are the possible outcomes? Sample space will be 1, 2, 3, 4, 5 and 6. These are the possible outcomes if I am rolling a die. And if I am flipping a coin, then the possible outcomes, or I can say my sample space, can be either I can get a head or I can get a tail. Now if I am doing this simultaneously, then the possible number of outcomes can be either I can get 1 head, 2 head, 3 head, 4 head, 5 head, 6 head, or I can get 1 tail, 2 tail, 3 tail, 4 tail, 5 tail, 6 tail. So there are total 12 possible number of outcomes. Okay. If I use the fundamental principle of counting, then directly I can say that there can be 6 into 2, that is 12 possible outcomes. Let us see with a different example. Suppose let's consider this example. A robot has to choose what to wear from the following: 4 slacks, 3 shirts, 2 shoes and 5 ties. Okay, so the possible number of outfits does he have to choose from? How many outfits are possible? How many different outfits are possible? That we have to find out. Okay, so total outfits will be given by 4 into 3 into 2 into 5, that is equal to 120. So we have seen that how we can use fundamental principle of counting to find out the number of ways in which 2 or more events can occur simultaneously without actually counting the number of ways. We have covered fundamental principle of counting, so we will start with our next subtopic, that is permutations and combinations. Okay, so now let's have a look at permutations and combinations. Stay tuned.